My dear students, I welcome you to this video. In this video, I am going to measure growth rate of GDP and other economic variables using three different methods. I'll be using some hypothetical data to compute economic growth rate of GDP, as well as I'll be using actual data for Pakistan that I have downloaded from the World Bank database, and I'll show how to compute economic growth rate of GDP for Pakistan. But since I'm using three different methods to compute growth rate, so let me explain and introduce you to this equation that is widely used in economics, and this is the formula for compound interest rate. And this means that the value of variable in time t is equal to the value of variable y in base period times 1 plus r raised to the power t, where t is a number of years and r is the compound rate of growth of y. Now, seemingly this seems a little bit confusing, but it is not confusing at all, because if I take natural log of equation 1 on both sides, I get equation number 2, where natural log of y t is equal to natural log of y naught plus t times natural log of 1 plus r. And in order to simplify this, I can write equation number 2 as equation number 3, where natural log of yt is equal to beta naught plus beta 2 t, where beta 1 is equal to natural log of y naught and beta 2 is equal to natural log of 1 plus r. Since this is econometric model and I'll be estimating this using observed data as well as hypothetical data, so I will need to add disturbance term to equation number 3. So finally I have equation number 4, where natural log of yt is equal to beta 1 plus beta 2 t plus ut. So as one of the three methods, I'll be using this equation to estimate the growth rate of GDP for Pakistan. So let me start with the hypothetical data. Here is the hypothetical data, and this data is let me do it again. I want to delete this and compute this again for you. So I have this data for GDP, and this is a hypothetical data. Since I'm using the log difference formula for this as well as the econometric model using log-lin equation or log-lin model, so I need to compute natural log of GDP. So this is the natural log of GDP for year 2000. So this is natural log of 500, which is the GDP for the year 2000. So if I copy this, I get the whole series. This is in log form, and here I need a trend variable, because as I showed it to you, I'll be regressing natural log of yt, that is natural log of GDP, on t. So for t I will use this trend. So let me do like this, and if I copy this, this is the trend. So I'll be regressing this on this, and if I do that, this is my output for regression, and the coefficient of t is equal to 0.07639. So if I round this, this becomes 0.0764, and if I multiply this by 100, so it means that the average growth rate from year 2000 to 2022, this is 7 points. The GDP has grown by an annual growth rate of 7.64%. I can calculate the same value by taking the log difference. So here is the formula for log difference, and what I do, I subtract this initial value of log for the year 2000 from this value. So as you see, this is C24 minus C2. So C2 is this, as C24 is this. So when I press enter, so I get this value. And this shows that the growth rate between this and this is 1.68, and if I multiply that by 100, so it means that the GDP has grown by 168% over the period of 22 years. If I want to compute the average annual growth rate of GDP, then I will divide this by the number of years. So here the formula is C26. So this is C26, and I have divided this by 22, which are the number of years. So I get 0.0764, and if I multiply this by 100, so I get exactly the same value which is here. So if I round it, so the growth rate using the log difference formula or the regression, the Log-lin formula, the GDP has grown by an annual rate of 7.64%. So here I have used two different methods, and I have computed exactly the same value of growth for the hypothetical data. Now let me open another file. Here is some hypothetical data. This is a initial value of y, where y is GDP, and here I have given this formula that this GDP has grown throughout by 5%. So using this formula, R is 0.05 and 1 is 1. So 0.05 means 0.05. So I get 10.5 for the second year, and if I let me also delete this, and then I'll create again. Okay, so this is the formula for this GDP from the first year has grown by 0.05, that is 5%. So if I copy this up to the end, so I got this, and I have already made graph of this series. So you see, this is the y series, and it has grown at an exponential rate. Then I have converted this data into log form, and I'll also do this again for you. Let me delete this. So how can I compute log of y? So parenthesis, so sorry, this should be natural log. So 2.30 is the natural log of 10. Copying this till the end, will calculate natural logarithmic series for me. And here I'm using percentage growth for calculating the growth rate. So there will be no growth for the first year because there is no previous value. For this I can calculate. So this value minus this value, this value minus this value divided by this value times so it means that the growth rate for this year is 0.05, that is 5%. And if I copy this, this gives me a constant growth rate for each year. So throughout annually the series is growing by 5%. I can also use the log difference. So the log difference can also be used for computing growth rate for this year. So this minus this, so it also gave me 5%. And if I copy this, you can see that both the methods give me exactly the same rate of growth if I use the percentage method or if I use the log difference method. So the growth rate is like this. Here you can see this is the graph of the series Y, and this is the graph of the log of Y. So this one has squeezed the data. We can also graph these two, and that will be exactly 5%. So this will be the graph for the two series. Now let me share with you, this is the actual data that I have downloaded from the database of World Bank. This is real data, and this data is from 1960 up to 2022 probably, and this is the actual data in US billion dollars that I have calculated from the World Bank, and then I have converted this data into log form. I can do this once more for you. Let me so let me do it for you again. Natural log of this. So this is the natural log, and let me copy this up to the end. So this will convert the whole series into logarithmic form. So these are the natural log of this. Now I'll also delete this so that I could calculate growth rate by percentage method, and then I'll use the log difference. So again, this is the formula. This minus this divided by this. So this is the formula for this, and if I drag this, this is also giving me growth rate by using percent growth rate formula, and I can use this the difference between the two logs. So this minus this log, so that gives me 9%, and using the percent growth formula, it gives me 10%. Let me drag this for this whole series, and these are the various growth rates for the various years. There is a little bit difference between the two formula. Now I'm using the trend for this. So then I will regress. Let me copy this for the whole series, and finally I'll show how can I use regression for computing growth rate for the actual or the observed data for Pakistan that I have downloaded from the database of World Bank. This is data for 63 years. Before I do that, let me share with you, I have made graph of the actual GDP in billion dollars, US dollars. So this is the graph of the GDP, and this is the graph of the log of GDP. Since log basically contract the data, it squeezed up the data. So this is the log, and then I have graphed the two growth rates. One is percentage growth, and the other one is the log difference. Since more or less they are exactly the same, so they are overlapping, except there is a little bit difference, and this is statistical difference between the two. Finally, I'm using the regression method to calculate the growth rate, and again I have used this equation, natural log of yt is equal to beta 1 plus beta 2 t plus ut, and you can see that estimating this model using this data give me the average annual growth rate of 0.0768, or if I multiply that by 100 I get 7.685%. So this is more or less the same. So my dear students, I have computed or calculated growth rate of GDP using three different methods. One is the percentage method, the second one is the log difference, and the third one is the log-lin model. And in the log-lin model, the coefficient of t tells us the relative change in the GDP due to a unit change in t, that is in years, that is equal to 1. So this is how we can calculate or compute growth rates for GDP. We may also use this formula for computing growth rate of other economic variables too, like money supply, investment, imports, exports, and so on. So this is very interesting and very useful, and you can use actual data in your research by calculating the growth rate of various economic variables. Ladies and gentlemen, I hope this is quite interesting for you and useful. Thank you very much for watching this video. Kindly subscribe to the channel and don't forget to click on the bell icon so that you can get timely notifications about my other videos that I'll upload for you. Kindly share various videos of this channel in various WhatsApp groups with your friends, with your colleagues, with your students, so that they could also get benefit